Hello, Algebra 1. Hey, it's the first math assignment video thing of semester 2, and I'm so glad that you get to be part of this. I just wish that it wasn't a video. I wish I was teaching you in person, but that's okay. Maybe one of these days. So here's a warm-up for you, and I just kind of purposefully gave you like a crazy equation just to try to help you remember that no matter how crazy the equation, the steps are pretty much the same. So go ahead and pause the video and solve for x, and then come on back and we'll solve it together. All right, so whenever you're solving for x, you're going to want to consider a few steps. And the first step is about simplification, taking a look at both sides of an equation separately and simplifying until you have no more opportunities to combine like terms and no more opportunities to do the distributive property. And once you've got that part done, all the simplification stuff, then you can move on to actually solving using algebraic steps like creating clever cancellations and making sure that you remember to do the same thing to both sides. And that's really all there is to algebra problems. There's some complications in there, but those three steps are really kind of the big, broad steps. So a couple of times while I was recalling that explanation, I said both sides. So we want to remember that equations have two sides, and I will draw a little dashed line down so that's very clear to me that these are two sides. And on the left side, we have a 48. There's nothing to do with that 48. There's no way to simplify it, and so we're just going to bring it down. And then on the right side, we have a mess. Now, as we read this part from left to right, we start with a 15. And it says, it might look like it says 15 plus 6 here. And a lot of folks will go ahead and add 15 plus 6 and then do distribution. This is not the correct way to proceed. And the reason why comes from the order of operations. You're going to take care of grouping symbols first, and you're going to take care of exponents, and then you're going to do multiplication and division in order from left to right, and then addition and subtraction in order from left to right. And so if you start with 15 plus 6 in this equation, you're starting at the end with addition and subtraction. And so that's not where you're going to start. Instead, you're going to remember that you start with grouping symbols and taking care of the things that are around grouping symbols. And the kinds of grouping symbols that we have are things like parentheses, square brackets, curly braces. There's all kinds of grouping symbols. So that's what you're going to want to look for first when you simplify. So we're not going to take care of that 15 and add it to the 6 because we're not going to start at the end. We're going to start with those parentheses. So since we're not going to deal with the 15, we're going to bring it down. And that brings us to the next part, the next term, which is this stuff right here. And notice that there's a grouping symbol in there. And so that's where we're going to start. We're going to take care of that business. And we're going to use the distributive property to distribute 6 times 4, which is 24. And then 6 times x, which is 6x. And then we've taken care of that part. Now notice that we still have a minus 3x. There's nothing to do with it, and so we're going to bring it down as well. Keep in mind that the order of operations is in effect when you're simplifying equations too. And that's why you learned it, because the 15 plus 6 would have led you in the wrong direction. You want to start with the grouping symbols first and then go from there. All right, let's take the next step. So we got rid of the grouping symbols. That's great. Now what we're going to do is combine like terms. So we've taken care of the grouping symbols. There are no exponents, and there's nothing to multiply or divide yet. And so we don't have to do that step. And that's what brings us to the combine like terms step. We're going to be adding and subtracting. But remember, we can only combine terms that are exactly the same. So we can combine terms like 15 and 24 together because both of them do not have an exponent, or sorry, a variable. we can combine 6x and negative 3x together because they both have an x. So even though we're adding and subtracting, we're not just pushing everything together, we're being careful that we're combining like terms. So 15 plus 24, let's see, that's 39. And then we have positive 6x minus 3x, in other words, positive 3x. And now we've taken that next step. Now when we look at this equation, we can see that on the left side it's completely simplified. It has been all this time. And on the right it's completely simplified because 39 and 3x are not like terms. There are no more parentheses. And now it's time to create clever cancellations and do the same thing to both sides. So you're going to start on the side of the equation that has the variable, but you're going to get rid of the part of the equation that does not have the variable. In other words, you're going to subtract 39, and you're going to make sure to do it to both sides. That is going to create this cancellation right here. On the left side, we have 48 minus 39. Yeah, I'm using a calculator. That's okay. That's 9, and that's going to equal the 3x that's left over on the right. Awesome. And so now we just really have one more step to go. We want to get rid of that 3 in front of the x, and so our clever cancellation would be to divide by 3 on both sides. This cancellation is created. 9 divided by 3 is 3, and all you have left over on the right side is x, and there's your answer. So it doesn't really matter how complicated equations get. You still want to remember that we want to simplify. Whenever you're simplifying, follow the order of operations. From there, once you're done simplifying, create clever cancellations and do the same thing to both sides. That's how equations work, friends. All right. Now's a good time to get out your notebook. Pause this video. You might, because this is the first math lesson of the semester, not have any questions to write or a summary to write. Great, but do get a page ready for today's notes. And what I mean by that is that if this is your page, you're going to make a line up here at the top and a line about 6 lines up from the bottom, and then a line like that, and that gets your pages ready. You're going to put the topic up here that's coming up next, and the essential question goes here. And today, you're going to take your notes in this section here. The next time you go to take notes, you're going to write yourself some questions about those notes in this column, and then later on you'll come back to this and you'll write a summary. And then that will be a complete page of notes. And if you do that every time you take notes in the big part, go back to some other notes, write yourself some questions, go back to some other notes and write a summary, then you're reviewing your notes all the time. And this is going to help you learn a lot. You will remember a lot more if you go back and review your notes as part of your note-taking process. All right, so here's the essential question. How can you solve equations with variables on both sides? The topic is solving equations with variables on both sides. Make sure that that topic makes it into the table of contents of your notebook, and the page number that you're on goes there too. So if ever you need to look up this topic, you don't have to sift through, 60 pages of notes to find it. You can just go right to it. All right, friends. So far, we've only been dealing with equations and inequalities where the variable, or x, b, the letter, is on one side of the equation. For example, we've been solving things like 3x plus 4 equals 13. Notice there's an x only on one side of the equation. We can solve this equation by, first of all, subtracting 4 from both sides. We have 3x equals 13 minus 4, which is 9, and then dividing both sides by 3, and we get x equals 3. But notice that x was always, there was only one x in the problem, and it was all on one side. Same thing is true with inequalities. Notice that the x is all on one side of the inequality. We're going to subtract 5 from both sides. That gives us negative 2x is greater than 11 minus 5. 5, 6, 7, 8, 9, 10, 11. Oh, it's 6. Okay, yeah, that makes sense. And then we're going to divide by a negative. Remember the big trick with dividing or multiplying negatives in inequalities, these still cancel. You still got x, but you have to flip the symbol because you're dividing by a negative. 6 divided by 2 is -3. Anyway, the point is that in these types of equations, and also in the warm-up, so far we've only dealt with equations where all the x's were on one side. But variables end up happening on both sides. And so we have to deal with that. Like, how do we figure that out? But I have good news for you. It's the same. It's the same. It's pretty much the same. So here we go. Algebra works in a very predictable way, friends, and if you will recognize that it's really a very few steps, within those steps there's lots to remember, I know, but they really are very few steps, and you can step your way through just about any algebra problem by simplifying both sides separately by either distributing or combining like terms, and then create clever cancellations. Do the opposite. If the problem's multiplying, you divide. If the problem's adding, you subtract. And then do the same thing to both sides. And that's going to get you through almost any algebra problem. So let's take a look at how our steps that we're familiar with apply to a problem like this. 5n minus 7 equals 9n plus 21. Now notice that there's an n on both sides, and whenever there's an n on the left side and there's an n on the right, let's create those sides so we're clear what we're talking about. Now it would be tempting to add 5n plus 9n. In other words, combine like terms. But remember that our simplify step, we have to keep the sides separate. So you can't do that in this one. So when we're looking at the simplification step, we have to look at the left side, 5n minus 7. Those are not like terms. There is nothing to distribute, and so there's nothing to do there. So on the right side, we have 9n plus 21. There's nothing to distribute. We cannot combine like terms, and so there's nothing to do. And so this is already simplified. We're done. So what we need to do is we need to create a clever cancellation. Now, here's what you do. Really, you could start anywhere with this problem. You could add 5n to both sides, but be sure you add it to the right term. You can't add 5n to 21 because it doesn't make sense. So you're going to line it up underneath the correct term. Oop. You know what else you could do? You could add 7 to both sides because that would create a cancellation there. And that would mean that you could add 7 to 21 on both sides as well. You could subtract 9n because then 9n would cancel. Make sure you subtract 9n in the correct place on the other side as well. And the last possible first step is to subtract 21. Because as long as you're creating a clever cancellation and doing the same thing to both sides, you can start pretty much anywhere with this type of problem once the simplification is done. Now I'll tell you what, I like to start here. And the reason why is because if I subtract 9n from both sides, that the variable ends up being on the left side. And I like that. So that's where I'm going to start. But you could start anywhere and we would still get the same answer. So I'm going to subtract 9n from both sides. Notice that I have created a clever cancellation because 9n's minus 9n's makes it go away. And I have lined up that 9n with the 5n, and I'm just going to solve that part. If I have $5, but I owe you $9, how many dollars am I going to be in the hole? Well, 5 minus 9 is -4, and then we just tack on that n. Now we haven't done anything with the -7, so that comes down, equals 21. So these kinds of problems, even though they have variables on both sides and they can start by kind of having a lot of first steps, are really just the same thing as we've always been doing. You can subtract whole terms away on both sides. It's okay. And now we have the kind of equation that we've had before. The n's are all on the left side. I'm going to add 7 to both sides. That creates this cancellation here. I have -4n equals 28. And then to get n by itself, I'm going to divide by 4. -4, sorry. N equals, gosh, I can't think of 28 divided by 4 at the moment, you guys. I hope you still trust me as your math teacher. I just don't hold those little math facts in my head. -7 is the answer. And that makes sense now that I think about it. So the point is, the steps are pretty much the same, but be careful when you consider that simplification step, that you're not trying to combine like terms over that equal sign, because the equal sign's like a wall, y'all. It just doesn't work. All right, let's do another one so that you can, see it again. So again, let's create our wall. And we're going to look at the left side, 15 plus 6x, nothing to do. You can't combine like terms. You can't distribute. On the right side, 45 plus 8x, use no distribution, no combining like terms, and so the simplification step is done. Now we're going to create clever cancellations, and we want to start moving these variable terms around. I like to take the variable term off the right side first. That's just where I like to start. So I'm going to subtract 8x from both sides. That creates this cancellation right here. Notice that I lined up that 8x under the 6x because those are like terms. I have 15, which comes down. 6x's minus 8x's is minus 2x's. And that's going to equal the 45 that's left over on the right. And now this is a two-step problem. You've done this kind of stuff a bunch. You're going to subtract 15 from both sides, creating this cancellation. You have -2x left, and 45 minus 15 is 30. And then dividing both sides by -2 is x equals -15. And you're done. So having variables on both sides of the equal sign is really just more of the same. You just have to be careful not to try to combine like terms over that equal sign. All right, so here's another one. Now this one looks a little bit different, but it's the same basic idea. You got x's on both sides, so you're going to have to look at each side separately to see if you can simplify. 12 minus 3x, not simplifiable. -6x is not simplifiable. And so we're going to create clever cancellations. There's nothing to simplify. On this one, I am going to add 3x to both sides. It's, you could add or subtract 12 from both sides, but all that would do is kind of move it over. You'd have to subtract, or rather add 3x at some point anyway, so I'm just going to start with it. Friends, as long as you are creating a clever cancellation, you're not doing it wrong. It's just going to be how you see it. Make sure that you're creating a cancellation, and if you're doing that, you're okay. The 12 comes down, and that's going to equal -6x plus 3x, which is -3x. And then this one-step equation can be solved by dividing by what's right next to that x, which is -3. 12 divided by -3 is -4, and that equals x. And there you go. It's not a whole lot different than what we've been doing. My slideshow won't change. All right, let's step it up a little bit. Let's kind of like make it a little bit more complicated. Let's create our sides. All right, so let's look at the left side. 5q plus 6. There's nothing to simplify. Nothing to do. There's no distribution, there's no combined like terms, and so I'm just going to bring the 5q plus 6 down, and that's going to equal, let's see, the right side, I see no distribution because there's no parentheses, but I do see 2q plus q. So 2 q's plus another q is 3 q's. And these go away. And then I can't combine the -2 with anything. And now we have completed the simplification step. This time we did have to simplify because we could combine like terms, but we're not combining like terms over the equal sign. We can't put 5q and 2q or the q or the 3q together. We can't. That equal sign is a wall. We have to wait until we can create clever cancellations to start bringing those things together. Simplification is separate. So now, to create a clever cancellation, I like to start with the variable that's on the right side if I can, and so I'm going to subtract 3q from both sides where there's a q. That creates this cancellation. 5q's minus 3q's is 2q's. Plus 6 equals -2. Don't forget that minus sign that's hanging out there. It didn't go anywhere. Now we've got 2q plus 6, so how about we subtract 6 from both sides? That creates this cancellation, and as long as you're creating a cancellation, it's hard to go wrong. 2q is left over equals -2 minus 6. Starting at -2, getting more -6 places, takes us to -8. Dividing both sides by 2, we have q equals -4. So sometimes you'll have to simplify first, but when you do, keep these sides of the equation separate. All right, let's get nuts. I think this is the last one. Kind of a long video, but you know, it's so much fun to do math, you don't mind, right? All right, friends, so we have created those sides. Let's take a look at simplification. We want to see if we can distribute. Remember that we're following order of operations, and so distribution is what we've got to do first because we have to take care of those grouping symbols. Now the 3x we can't really do anything with because there's nothing to combine it with at this point. There will be in just a bit. We've got to get rid of those parentheses, and when you're distributing, you're dealing with that number that's right next to the parentheses. Notice this 8 comes, though, with a minus sign in front of it. And so when you distribute, you're going to distribute -8 times 2x for -16x, and -8 times +3, or -24. Okay? We have taken the first step in simplification on the left side. Now let's do the right. We have to distribute, right? Because there's parentheses. We have a -6 times 2x for -12x. We have a -6 times +5 for -30. All right? There, we've gotten rid of the distribution, so we're done with this part. And now we're going to combine like terms. Let's look at the left side. We have 3x's minus 16x's, so we can simplify right here because we've got like terms. So let's see, what's 3 minus 16? -13, duh. I don't know why I needed a calculator for that. 3x's minus 16x's is -13x's. The -24 doesn't have anybody to combine with, so it comes down. And then on the right side, we've got -12x and a -30. They cannot combine, and so -12x minus 30 comes down. Okay, so now we've combined like terms, and it's time to create clever cancellations. Because if you look at the left, there's no more like terms to combine. If you look at the right, there's no more like terms to combine. And so now we need to start creating clever cancellations. And again, I like to start on the right and work with the term that has the variable first. So this is a -12x, so I'm going to add, 12x to both sides. That creates this cancellation. I have -13x's plus 12x's for like a negative 1x minus 24 equals negative 30. Now, just as a side note, sometimes you'll see this as a negative x. That's exactly the same thing. And in fact, you're going to see that a lot. And so here's what I'm going to do. I'm just going to work this problem like that. Keep in mind that negative x is the same as negative 1x, okay, as we go through this. But I want to work the problem with negative x so that you can see how to work with it when you're getting into your homework. Okay, so we have negative x minus 24 equals negative 30. Let's add 24 to both sides. Why not, you say? I don't know. No good reason not to. And then these cancel. Now we have negative x left here equals negative 30 plus 24, which means we're starting at negative 30 and we're going in the positive direction 24 places. And we get to negative 6 when we do that. All right. So we have negative x equals negative 6. So how do we get rid of that negative? Well, we can remember that negative x is the same as negative 1x. And so we could like multiply both sides by negative 1. We could divide both sides by negative 1. We could think through it. It says, well, if negative x is equal to negative 6, then x must equal 6. But we can also just kind of write it like this. Maybe we can divide both sides by a negative. These negatives cancel. We have x equals. These negatives cancel, and we have 6. There's any number of ways of thinking about it. All right, you guys. So that's it. I hope that that wasn't too confusing. Basically, you're still just kind of doing the same thing as you've always done. Look for opportunities to simplify by distributing and distributing and combining like terms. And when you're completely done with simplification, then look for opportunities to create clever cancellations, making sure that you do the same thing to both sides. The essential question, how can you solve equations with variables on both sides? You should be able to answer that after this lesson. Maybe not like super confidently, but you should be able to have a pretty clear idea. If not, look me up. I'd be happy to help. Your practice is on Big Ideas Math. Log in there and get that done and let me know how I can be helpful. Have a great day, you guys. Bye.